Okay, you guys ready to dive into our next lesson? Well, let's do it. Let's go use total surface area and lateral surface area of pyramids and cones in order to solve some problems. Now, pyramids and cones are very much like prisms and cylinders, except there is a difference that we're going to talk about here in just a second. Because if you realize, both of these figures right here are slanted. They come to a point, don't they? They don't have two bases, do they? They have one base. Okay, so how does that make a difference? Well, when we're talking about total surface area, remember total surface area is everything on the surface, the area of all the faces added together, including the base. Lateral surface area is just the lateral faces, does not include the base. Now, we just have one base, don't we? Okay, so what else is so different? Well, guys, do you guys see how I said that these guys are slanted? They come to a point, don't they? So we have a special thing called slant height. Let's go take a look at what that is. Okay, so we are going to be dealing with these formulas. Okay, and right here we've got lateral surface area and total surface area of pyramids. But I want you guys to notice right here, this is like a lowercase cursive L. Okay, so it would look like something like this. Okay, that stands for slant height or lateral height. Okay, so why do we call it a slant height? I'll show you why. Okay, so guys, in a pyramid right here, okay, all of the faces in a pyramid are triangular. Okay, these are triangles. And you guys know how to find the area of a triangle, right? 1/2 base times height. Well, here would be the base, and right here would be the height. Well, guys, that height now is slanted, isn't it? So that's why we call it slant height, because the height of that triangle is now slanted, and the height of the pyramid goes perpendicular to the base. The height of the pyramid is not slanted. So we have to differentiate between slant height and regular height of the pyramid. Okay, so does this apply to cones as well? You betcha. Okay, so if we go down and we look at the cones, okay, so we've got let me get that where you guys can see it. We have got the formulas for lateral surface area and total surface area. And yes, guys, look right here. There is the slant height of the cone as well, because, hey guys, look, isn't a cone also slanted? So yeah, it's going to have a slant height as well as a regular height. Okay. All right. So how do we do all this? Well, we're going to go take a look. And guys, I'm going to work out a pyramid problem with you first. So let's go down and take a look at number 4 together. All right. So down here at number 4, guys, we have a pyramid, but we got to figure out what kind of pyramid is this? Well, we're still going to name the pyramid by the shape of the base. So can you guys tell me what would be the name of this pyramid? Did you guys notice that we have a 1, 2, 3, 4, 5-sided base? So that is a pentagonal pyramid. Okay, now if I have a pentagon, these are regular pyramids. That means that that is a regular polygon. Oh no, that means we're gonna have to go through some crap. Yes, you are. Okay, but guys, I want to show you some parts that on this particular thing. Okay, so look right here. We've got the 9.1 inches and the 8.3 inches, and we've got these lines. Well, what does that all represent? So let's deviate for just a second. I want to show you guys this. So if you guys notice right here, I've got this pyramid. Oh, and there's the lateral height or the slant height on the outside of that triangle. And look, check this out. See that green triangle that's inside? Hey, there's the height of the pyramid. And, oh, there's the slant height of the pyramid. That makes up 2 sides of that triangle. And the base of that triangle is the apothem. Oh, the apothem, because remember, the apothem and the radius, remember we have the radius that goes from the vertex to the center. We've got half of our central angle, and the apothem goes to the side. And remember, it bisects that side length, doesn't it? Okay, so guys, isn't that cool? Like, that is so cool, but y'all know me. I'm a big old geek, aren't I? I know. Okay, so we had that pyramid. So I showed you guys some parts to this. Okay, so what does that look like? Well, that means that if we look, we've got, oh, let me do this a little bit better. If we look right here, the 9.1, guys, the 9.1 is pointing to this part right here. Okay, so if I put up the pyramid again with the green and the pink triangles, the 9.1 inches represents what? What part of this pyramid does that represent? Yeah, the 9.1 is the height, the H, the height of the pyramid, isn't it? Okay, all right, well then let me put up a picture again, okay? What about the 8.3 down here that I just highlighted in green? The 8.3, what part does that represent? Yeah, the 8.3, guys, that's our apothem, isn't it? Oh, wait a minute, apothem, and we have a regular pentagon. Yes, we're going to get to go through the crap, right? But hey, we already have the apothem. It gave us the apothem. Okay, so let's go ahead and write that down. Our apothem is 8.3 inches, and that was given to us. There's no work for that. It was just given to us. Okay, well, guys, if you notice on this page, it's asking us for a whole bunch of things. Okay, so let's go down. We're going to go down the column. And the next thing it's asking us for is big P. Now, guys, remember, that is perimeter of the base. Okay, so our base is a pentagon. Now, I'm going to attempt to draw this the best that I can. Guys, bear with me. All right, so I'm going to redraw our base. Okay, so I have part there, a part there. All right, well, it's not exactly perfect, but like I said, okay, it's there. Okay, so we have the pentagon. Now remember, we already know the apothem. The apothem goes from the center. It's perpendicular to the base. We already know that that is 8.3 inches. And we know that the apothem bisects the side, doesn't it? Okay, well guys, we're going to have to, in order to find the perimeter, we're going to have to draw in the radius, right? Here's our radius. We're going to have to draw that in, and we're going to have to find half the central angle. Okay, so now guys, what I just drew in, I'm going to put this picture back up here for just a second. Guys, what I just drew in is that pink triangle. That is the triangle that's on the base. Okay, that's the one that I'm working with right now. Okay, so if I zoom in on this particular triangle, okay, remember, this angle right here is half of the central angle. Okay, so what would the measurement of this angle be? Yeah, guys, that's going to be 36 degrees. Okay, and now we're looking for this side length right here because we got to find the perimeter. Okay, so you guys have become masters, hopefully, of trigonometry. So I want you guys to go and I want you to solve and tell me, what do you get for x? How'd you do? Okay, did you remember to label your triangle with opposite, adjacent, hypotenuse? We're going to use the tangent function. Okay, so x is 6.03. Now, guys, remember, do not round to the tens place until the very end, until you're ready to put that answer on the line. Okay, so now, that is half of our side length, isn't it? So to get the entire side length, in order to find the perimeter, remember we have to multiply this by 2, right? To get the whole side length. So the whole side length is 12.06. That is the whole entire side length. So this is S, isn't it? Okay, and then to get the perimeter, okay, oh, wait a minute, Ms. Smith, you're moving everything around. Yep, okay, so to get the perimeter equals the number of sides times the side length. So the perimeter equals the number of sides is 5 times the side length, 12.06. Okay, now, guys, when you put that in your calculators and you end up rounding, you should get 60.3 inches. Okay, 60.3 inches. All right, so we've got the perimeter now. All right, let's see. What else is it asking us for? Let's keep going. Okay, so we've got, oh, it's asking us for big B. Okay, well, we've already gone through part of the crap, you guys. Okay, so big B. Big B is the area of the base. Okay, so which formula are we going to use to find the area of the pentagon? Did you guys remember? It is a regular pentagon, so we're going to use the formula for area of a regular hexagon, 1/2 AP. Okay, so area equals, guys, you're going to go plug that in. You have the apothem, you have the perimeter. Can you guys tell me what is the area of the base? All right, how'd y'all do? Okay, did you remember that this area is in squared units? I have been saying that over and over again, haven't I? Okay, all right. Now, let's zoom out and let's go look at what we've got now. Okay, the next thing, if we look, it's asking us for that cursive L. All right, let me zoom back in here. That cursive L. Hey, what does that stand for again? Yeah, guys, that cursive L, that is our slant height, isn't it? Okay, that is the slant height. Okay, so slant height. Well, where is the slant height on this particular figure? It's not labeled for us. So guys, you're going to need to draw it in. Now, when you draw it in, I would recommend draw it in with a dotted line. Okay, so it might look something like this. The slant height goes down the side of the pyramid, okay, and remember, it's on the face, isn't it? Okay, so I just drew in the slant height. Okay, now, this is where, you guys remember those two different triangles that were inside of our pyramid. This is where now we're going to focus on the green triangle, because the green triangle is the one that stands up in the pyramid, isn't it? Okay, so, all right, let's look. If I redraw that green pyramid, okay, and I'm going to put, like, watch what I do, all right? So if I redraw this, okay, right here, and I said green pyramid, I meant green triangle, right? If I redraw that green triangle that's in that pyramid. All right, so this side, which is the height, is 9.1. Okay, down here, this is the apothem. That one's 8.3. Okay, and then this right here is our slant height. Okay, so if you notice what I just redrew on the sheet, guys, it's a representation of that green triangle that was inside that pyramid. Okay, I want you guys to go and I want you to solve for the slant height, okay? And then don't forget your units. Tell me, what do you get for the slant height? All right, how'd you guys do? Did you remember that you have to use the Pythagorean theorem? Because we don't know an angle, do we? Okay, we don't know this angle up here at the top of the pyramid. We don't know that. We don't know this angle down here, but we do know two side lengths, and we want the third side length, so we can use the Pythagorean theorem. Okay, all right, now let's go and look and see what else is it asking us to find. LSA. Okay, LSA. Well, in order to find LSA, guys, we're going to need a formula. So, which formula is the correct formula to use for the lateral surface area of this pyramid? Okay, did you guys get the right formula? Okay, lateral surface area equals 1/2 PL. All right, hey guys, work your magic. You guys have the information you need. Go plug it in and tell me, what do you get for the lateral surface area of this pyramid? All right, my mathematicians, how'd you guys do? Okay, did you remember lateral surface area is in squared units? Okay, so again, guys, once we pick out the right formula, now we just got to figure out what to plug in. Okay, well, having said that, the last thing it's asking us to find is surface area. Okay, so which formula should we use this time? Did you guys pick the right one this time? Well, hopefully so. If not, guys, this is the formula for the surface area of a pyramid. Notice there's only one big B, one base, right? Okay. Hey, guys, you know what to do next. Go work your magic. Tell me, what do you get for the surface area of this pyramid? Good job. Okay, now that you guys picked out the right formula and you plugged in all your values, you should get 621 inches squared. Okay, good job, you guys. Now, I want you guys to look. This was a lot of information, wasn't it? There was a lot of steps that we had to go through in order just to solve one problem. And if you guys noticed, I wrote down the formulas every time. So make sure you write down your formulas. Okay, you guys ready to shift gears and go to something else? Bum, bum. All right, let's go take a look. Hey guys, let's go down to number 11 and let's work that one out together. All right, here at number 11, you guys, now we have a cone. Now, I'm going to work this one out with you because it gives us the surface area. And we need to work backwards in order to find the height and the slant height. Oh gosh, how are we going to do that, Miss Smith? Well, ladies and gents, the very first thing, we need to figure out a formula. We need to figure out which formula should we use in order to solve for the height and the slant height. So let's go take a look. Guys, if you look at the formulas for surface area and lateral surface area of a cone, guys, if you notice, they include pi, they include the radius, and they include the slant height. Okay, so then what we can do is we can say, okay, wait a minute. We already have, guys, if you look right here, we already have the radius. As a matter of fact, I'll circle it in blue. Okay, we already know the radius. We know that pi is in our calculator, right? It's programmed in our calculator. The only thing we don't know is the lateral height, okay, or the slant height. But wait, we know the surface area. Oh, so if it gives you the surface area, start with that equation. Okay, so surface area equals, hey guys, which one of the formulas should we use again? Yeah, we need to use that pi r squared plus pi r l. We need to use that equation. Okay, so let's plug in what we know. We know the surface area, right? It gives us the surface area right there. So we're going to plug that in. So that is 395.8 equals pi. Plug in the radius. We know the radius. The radius is right here, isn't it? That is the radius, the 7. Okay, so 7 squared plus pi, plug in the radius again, 7. Okay, and then L. Now, we don't know L. This L that I just put there in blue, that's our unknown variable. That is what we are going to solve for. Okay, so, ladies and gents, now you're going to go through all of the algebra, okay, and I want you guys to go, and I want you to tell me, what do you get for the value of L, which is representative of the slant height? What do you get? All right, how'd you guys do? Well, let's see. You should have gotten 10.99 equals L, and then when we round it to the tens place, this 9 rounds up that 9 to 10. So that means that this has to go up by 1 digit. So our slant height is 11 centimeters. Okay, 11 centimeters. Okay, now, guys, take a look at my work just in case. I want to point something out. Did you guys also remember when you divide by pi 7, you've got to put it in parentheses, right? If you didn't put it in parentheses, you got something completely different, okay? All right, so that's the first step. Well, now we know the slant height, right? And we still know the radius. Let me pull this back over here. So how does that help us find the height? Okay, so I'm going to zoom in here, and we're going to look at this cone. I'm going to actually put the 11 centimeters. 11 centimeters is right there. Okay, so guys, we know the radius. We know that this side is 11 centimeters, and we're looking for the height. Hey guys, I just drew in a right triangle inside that cone, didn't I? Oh, I see what you did there, Miss Smith. See, I'm pretty sneaky, aren't I? Okay, so guys, now what we can do is we can actually go and draw that right triangle, and we can solve for the height. So what does that look like? Well, guys, this is what it looks like. Here is the height. Here's the H. Okay, right here is our radius. That's 7. Right here is the slant height that we just found. That's 11. And remember, the radius and the height are perpendicular in a cone. Okay. Hey guys, we just kind of worked one out like this just a second ago, didn't we? All right. So why don't you guys take it from here, and I want you to tell me, what did you get for the height of this cone? All right, y'all, did you remember that you can use the Pythagorean theorem, right? And once you solve it and round to the tens place, the height is 8.5 centimeters. Okay, so we've gone over a couple of different things together, okay? And let me come back up here. We've gone over a couple different things with pyramids and cones. And if you guys notice, really the main difference is that now we have lateral height. We have that slant height, okay? Just remember that that slant height helps to create a right triangle inside the pyramid and the cone. All right, guys, as usual, ask questions when you have them, and we'll see you guys in class. Adios.